Okay, I would say then we can continue with the workflow how to import the transient MIKE SHE raster datasets into MODFLOW, or in other words, how to convert the DFS2 raster datasets into the recharge package input file. I also have here a clean folder, a new working flow folder, example 5. I will do it now with the version 2005. You will get from us a data package after with the recording. And inside there, I can show you already now how it looks like. You will find here also a folder that gives you the 2 Jupyter notebooks that we created for you. One for a MODFLOW 6 model and one for the 2005. I will go with you now through the workflow for the 2005 version. I have here a clean folder. I have here a transient model muse MODFLOW file. I have here my working folder. I have a transient recharge grid that I produced exactly for this model. And the first thing you need to do, you need to install a virtual environment. Just in case you get lost within the steps, there is this new online manual. I will probably show it to you many times now in this webinar. If you start here with the MIKE SHE online manual, you can go here to applications and to recharge modeling. And within these sections, everything is described, especially when you want to integrate MIKE SHE with FEFLOW or MODFLOW. You also find here the links to the YouTube videos that show you exactly the steps that I do right now. If you want to do it with MODFLOW, you find here a short description and how it works. Just in case you are new to Python, you can also follow this link here, and you will be guided to another location in the online manual that shows you how to download, install Python, Visual Studio Code, and UV, which is needed in order to, or which is recommended to install Python packages and then set up virtual environments. Now, I will not do this installation process with you now. Instead, we will start here in our working directory. The easiest way to start a command prompt and to create a new virtual environment directly in this working folder is you click into the link, press type cmd.exe and press enter. That will bring you to this working path. Alternatively, you can also copy this path, open the command prompt here from the Windows. And with cd, you can go also to this directory. Now, in order to create now here a new virtual environment, you simply press uv venv. Then it's created. You see this also here in the folder. Now it's here. Then you need to activate the virtual environment. It's activated. You can see now here, this working folder is here, pasted into the beginning. And now you need to install the required packages for the Jupyter notebook. I do that now ideally directly in editing here with a text editor, the Jupyter notebook, and copying me here the section that tells me what I need to install. I can see that here, pip install MikeIO and so on. These are the packages you need. They use MikeIO and FlowPy with the built-in functions. And now, because we do here the package installation, you need to also type UV and the rest. And then you press enter, and then it's downloading and installing the required packages to this virtual environment. This takes now a couple of seconds. And now we are done. Now I open Visual Studio Code in order to run and edit the script. In order to make Visual Studio Code recognize this new virtual environment, the easiest thing is that you really open a complete folder. Now in this case, my folder example 5. Now I see here in the Data Explorer my recharge file, my model example, and the 2 Jupyter notebooks. And I open now the 2005 one. It's loading. Then you need to select here the kernel. One left click. I click on Python environments. And now it's already suggesting to me here this recommended virtual environment, which we just have set up together. Now it's running. Could be that you still have outputs here from the previous run. No, that's already deleted. But I clear here all my outputs just to be sure. And then I will press run all. Now it takes a little bit of time. It sometimes tells you what is still missing. Now in this case, the IPy kernel and the pip package. So I install them. You see it's running here downwards, down lower right end, and we wait for that. In the meantime, we can go through the script until this is running. So what you always need to do, as I said, you need to install these packages before you open the script, and then it imports them in the first step. Here are also some comments. You always need to change this to the relative folder of your model folder of your MODFLOW model. You need to change here the num file name of your model. Try to consider the correct EPSG code for the correct geographical reference system. And this is how you would like to name the top layer cells shapefile. I will show you in a minute for what you needed. This will be created then here on the top folder next to the script. Then it's loading the MODFLOW file with FlowPy. It's inspecting the model grid and finding out what is currently stored there. Then it imports pandas and goes here through the time steps. It will recognize or read the discretization package and find out if you have stress periods. It will create polygons now for the top layer cells and write it to the defined output. It will now in a minute show here also an optional quick plot and then write the shapefile. It optionally writes also a geo package instead, which can be used for the QGIS workflow. Now it's coming, you can see it. Here is now the model inspection. I directly go to the bottom to see when the final comparison plot will be created. Now it's already running. So this is now created. I will go back to the middle of the script so we can finish here the quick run through the script. Once the top layer cells of the MODFLOW model are created and read, it does a troubleshooting and inspect the model grids, both of them. If they are matching each other, then it's reading also the DFS2 recharge. Here you need to set the timestamp of the beginning. Now in this case, it's the 1st of July of the year 2000. The temporal aggregation is at the moment set to mean. Feel free to read this Python code yourself and decide on a different way. Now in this case, I assume that you want to work in meters per day. So the conversion factor here is 1000. If you want to change it to feet today, this is up to you to change here the factor. Then it will create also raster cell polygons for the TFS2 raster. This is needed for the spatial mapping. And then it will this lookup table with the area weighting. So it will overlay the two polygons and then see to which percentage which DFS2 raster cell needs to be assigned for each MODFLOW cell. You see here some information about the rows and columns. Different counting is also considered here. And then it projects one DFS2 timestep to the MODFLOW grid as a first step. And then it projects all the DFS2 timesteps to the MODFLOW grid. It will also consider temporal linear interpolation, a mass conservative temporal interpolation, just in case, which is quite common, that the MIKE SHE output timesteps do not match the MODFLOW timesteps. So it will be also mass conservative in terms of the temporal assignment. Then it shows you from time to time here what it does internally, and then it will write this to a recharge model file. At the end, we implemented here also a short visual inspection kind of. On the left side, you see the raw DFS2 input file averaged over all time steps. with a quite high resolution now. You can see it here. And on the right side, you see the averaged recharge rates on the MODFLOW grid in real X and Y dimensions. If the Jupyter Notebook recognizes a steady state model with the flag inside the MODFLOW file, it will automatically average all DFS2 time steps of the MIKE SHE model and assign it as steady state recharge. Now here you can see already that the spatial pattern more or less looks correct. It's always, of course, recommended to check the mass balance, of course, carefully with the MIKE SHE modeler. Now, if we go into our transient model file, you can see that here two packages are, this is only the recovered file fraction. But here we have now our new recharge file containing the DFS2 files. If I right click edit here in Notepad, you can see here stress period 1 and the values like we produced them with MIKE SHE. And this should now be able to run your MODFLOW model. Now, just in case you want to give it a quick start and you do not have too many datasets, but you want to test if this assignment works for your MODFLOW model, what you actually can do is you download and install MIKE0. I will show this in a minute. And you create a very quick and simple MIKE SHE model yourself. So you open MIKE0, create a new file, MIKE SHE. You turn off all the unimportant modules. We keep it very simple. And now you actually can directly use this shapefile as a model domain for a very small and quick test. Okay. Okay. Now we leave the topography to a standard value. The test datasets that I will send to you will also contain precipitation and evapotranspiration rates. You can follow here the recording. So we changed the spatial pattern to time series. Yeah. Now in this case, I need to align the simulation period. Now it works. You can also do this in demo mode without a proper license, because you're able to run very simple models. It's again the start date that does not work. I will correct that before you get the data. But we can now choose another example that was already working. Just one moment. Yes, this works now. And you leave everything as constant. That's fine. So we save this here. Run it for 1 month so that we have these 30 stress periods. And within a couple of seconds, you will produce. You need to check the total recharge to be produced. This is not on by default. So we click again on pre-processing and run it for 1 month. So even with demo limit restrictions without a proper license, you can create yourself here this one, the 2du set all cells file, and put it here to the very top. Now I recommend you, there are normally stored several items, so you can edit items, select these ones and delete them so that the script is not getting confused. Now you see changing values, even if they are unplausible. Now we change here at the very beginning the name of the DFS2 file. And run it again. Now you see unplausible values, but this is a quick start for you to see if the import works on your MODFLOW file. This is quite a new approach for us also. So if you want to test it, I'm more than happy to help you to look over your shoulders if you want to test this import. If you run into problems, please don't hesitate to write me an email and text me. I'm more than happy to debug and improve further this Jupyter notebook with your help if it does not cover any of your edge cases. So we are done now with the MODFLOW workflow.